Right, how's it going? My name's Andy, and I'm going to teach you calculus because I don't know. I just feel like teaching calculus. So, before we get into calculus, well, what is calculus? It's basically the study of curves. So, we're going to be able to find the area under them, we're going to be able to find the rate of change at a specific point, and stuff like that. So, but before we get into this, we need to learn about some little function right here, the limit function. And what that is it tells you that as something goes to a number of this function, you're basically plugging in x. But because it's got limit right here, and let's say you got a function that doesn't compute correctly, it tells you that you could just find whatever this function approaches when x is set to that value. And to explain what I mean, I'm going to show you some examples, because I understand that that wasn't the most concise wording. So right here we got the limit as x approaches 7 of x squared. Now limit, that basically means plug in. So let's say, we just 7 squared, and that is 49. And so we can say the limit as x approaches 7 of x squared is 49. But let's say we go to something a little bit more complicated. This limit right here. Limit as x approaches 0 of 1 over x squared. Well, what the are we going to do here? It's not very obvious, because if you plug in 0, then you get undefined, and you don't know what an undefined is. There's a way to evaluate a limit without, messing with numbers. You can just look at its graph, and, well, if we were to get like a graphing calculator in here, we would see that this is roughly what 1 over x squared looks like. We can see that, here's 0. As x goes to 0, y goes way up to infinity. So we can tell that that's infinity. So it's still basically evaluating things. And we're going to do this two ways now, because this you're thinking, well, I can just plug in 2. Well, you can't, because if you plug in 2 for x, you get 2 minus 2 on the bottom, which equals 0. And then you're left with undefined again, so what's the answer? Is it infinity if it's always undefined? Not necessarily. Because if we look at the graph for this thing, it's basically a line. It doesn't curve up. No, it doesn't do that. So how do we figure this one out? Well, we factor the top. Whoa. So, all right, so we got 10 here. The factors are like that. And, well, it's definitely got to be this one, because what else adds up to 3? So we know x minus 2, x plus 5 over x minus 2. And we take the limit of that as x approaches 2. Well, do you notice anything that we can cross out here? Well, we can take away this x minus 2, and then we're just left with x plus 5, and we can definitely plug into that. So 2 plus 5, 7. So we know as x approaches 2 that this function, well, this function right here, is going to approach 7, because we got rid of that term, we simplified it. And if we look at the graph, yeah, it's true, it does approach 7. I mean, this isn't very linear, but on my graphing calculator right next to me, it approaches 7. Now, the reason why we can't compute it in the first place is because if we were to draw this, and then if we zoomed in like maybe about 100 times, there would be a gap here, also known as a hole. So that's the main reason why it actually look a little bit more like that. But you can't evaluate it there because this term is going to become 0. And that's basically what a limit is used for. It's for evaluating something when there's either a hole or it just goes off to the middle of nowhere. And let's see. This one. Okay, so yeah, I was looking at this because I was like, wait, you can evaluate that, and I made a boo-boo right there. That's supposed to be a 0. So limit as x approaches 0 of 5 plus x all squared minus 25 over x. Well, you know that you can't just plug it in because you get something over 0. So that's out of the book. So why don't we try just multiplying this thing out? So 5 plus x minus 25 over x. And by the way, this notation, I mean, sometimes I don't write it, but just make sure that you got it at the end. Otherwise, your teacher might get mad. Anyway, all right, so this is going to be 25. It's foiling. Plus 10x plus x squared minus 25 over x. And if we notice something, well, that just cancels out right there, so we don't have to worry about 25 anymore. And we're just left with 10x plus x squared over x. And they both have an x, so we can just wipe out an x. We get x plus 10. And now we just know we can plug that in now. There's nothing to go over. And that's just going to be equal to 10. And that's basically what a limit is. You're finding the value of something that you ordinarily wouldn't be able to find the value of. You're finding its closest value, if that makes any sense. Anyway, that's all I got for you today. Stay tuned. If you like it, tell me that you like it, because I want to make more of these videos, and I want to teach you guys how to do calculus. Anyway, peace out.